Lesson 3.6 is all about adding and subtracting fractions with unlike denominators. So in 3.5, we learned that when fractions have a common denominator, we can just add or subtract the numerators and keep the denominator. The same thing is when they have an unlike denominator, we're going to do the same thing, but first we have to get them to have a common denominator. So write down this first example of 4/12 plus 2/5. We need to think of a common denominator of 12 and 5. And when in doubt, you can always multiply them together. So, for example, 12 times 5 is 60. So we know that 60 can be used as a common denominator. Well, to get 12 to 60, I have to multiply it by 5. And whatever I do to the denominator, I have to do to the numerator. 4 times 5 is 20. Because 4/12 and 20/60 are what we call equivalent fractions. They're the same thing. We're not changing the value of it. 2/5, to get 5 to 60, I have to multiply by 12. So I have to multiply 2 by 12. 2 times 12 is 24. Now I'm going to add these together. 20 plus 24 is 44, and I keep the denominator. Then I always need to put my answer in simplest form. So I am going to divide each of these by 4. 44 divided by 4 is 11. 60 divided by 4 is 15. Can't simplify that further, so my answer is 11/15. Then we have -5/9 minus 7/8. So we need to come up with a common denominator. 9 times 8 is 72. And I don't think there's one that's smaller that we can do. So let's use 72. 9 times 8 is 72. So I'm going to take -5 times 8, because whatever I do to the denominator, I have to do to the numerator. -5 times 8 is -40. Don't forget about your negative. And then 8 times 9 is 72. 7 times 9 is 63. So now the denominator is going to be 72. And what I'm going to do is I'm going to add up here. Instead of minus 63, I'm changing that to plus negative, because now I can use my rule of same sign, add and keep. -40 plus -63 is -103. Then to simplify, 72 goes into -103 -1 time. And then we have to figure out what's left over. So what do we have to use to get from 72 to 103? So I take 103 minus 72, and I'm left with 31. And then I always keep my denominator. Then we just double check quick. Can we simplify this any further? And the answer is no. So there is our answer. -1 and 31 over 72. Okay, working with mixed numbers. I think the easiest way to approach this, if you want to change them to improper, that's fine. You can do it that way. But let's try doing one where we just change the fractions and not the whole numbers. So -4 and something minus 2 and something. That looks a little confusing right now, but we'll fill it in. So I look at 5 and 11. A common denominator would be 55. So we're going to get both of them to have a denominator of 55. To get 5 to 55, I multiply by 11. Whatever I do to the denominator, I have to do to the numerator. 2 times 11 is 22. And then 6/11, I have to multiply 11 by 5 to get it to 55, which means I have to multiply 6 by 5, which is 30. And now I can change this minus to a plus negative. And now what I can do is I can add together these numbers. So -4 plus -2 would be -6. And then 22/50 plus 30/50 would be 52. I'm sorry, 50 over 55, not 50ths. So it would be -6 and 52 over 55. 52/55. Yeah. All right, then we have 2 1/3 plus 6 3/5. So these have different signs. So I know I'm going to subtract, but before I even do that, I'm going to change this 1/3 and 3/5 to have common denominators. So I'm going to rewrite this as -2 plus 6 and something. Looking at 3 and 5, common denominator would be 15. 3 times 5 is 15, which means I have to multiply 1 by 5, which is 5. And then 5 times 3 is 15, so I multiply 3 by 3, which is 9. Now, since they have different signs, I'm going to subtract. I'm going to take 6 and 9/15 plus, or I should just say minus, 2 and 5/15. 6 minus 2 is 4. 9/15 minus 5/15 is 4/15. So our answer is 4 and 4/15. When we simplify variable expressions, we have a over 2 minus a over 6. Again, we can't subtract until they have common denominators. So a common denominator between these two would be 6, which is nice because then we can just keep our second fraction the same. And to get our first fraction to have a denominator of 6, we have to multiply it by 3. If we multiply the denominator by 3, we have to multiply the numerator by 3. 3 times a is 3a. Then I can just subtract the numerators and keep the denominator. 3a take away 1a leaves me with 2a. Then I just have to simplify. I can divide both by 2, and I'm left with a over 3. And there's my answer. Then we have negative 5y plus negative 3 over, negative 5y over 6 plus negative 3y over 9. Looking for a common denominator, I can get these both to have a denominator of 18. So to get 6 to 18, I have to multiply it by 3, which means I have to multiply negative 5y by 3. So 6 times 3 is 18. 3 times negative 5y is negative 15y. And then 9 times 2 gets me to 18. And negative 3y times 2 gets me to negative 6y. And now I can keep the denominator and add negative 15y plus negative 6y. They have the same sign, so I add and keep. I get negative 21y. And then I'm just going to simplify this by dividing both numerator and denominator by 3. And I'm left with negative 7y over 6. All right, and lastly, this says an ice sculpture originally has a height of 74 1/4 inch. So that's positive, 74 1/4 inch. The ice sculpture begins to melt, and after several hours, the height has decreased by 8 7/16 inches. So we're going to subtract 8 7/16 inches. What is the current height? So again, we want them to have common denominators. So I'm going to rewrite this as 74 and something minus 8 and something. Looking at 4 and 16, well, a common denominator would be 16. Which is nice because then we can keep our second one the same. So we just transfer over the 7. And then 4 times 4 is 16, which means I have to multiply the numerator by 4. 1 times 4 is 4. And now, to make our lives a little bit easier, we're going to use that borrowing strategy that we learned from lesson 3.5. Because if we change these to improper fractions, we're going to be working with huge numbers. So 1 whole here is equivalent to 16 sixteenths, right? Our denominator is 16, so if we have all 16 parts, we have 1 whole. So what I'm going to do is I'm going to borrow 1 whole from 74, and I'm going to change this to 73, and then I'm going to add 16 sixteenths, that 1 whole, plus my fraction of 4 sixteenths. 16 plus 4 is 20. And I keep my denominator of 16. So now I have 20 sixteenths minus 8 and 7 sixteenths. And here's why that works nicely. Now I can just take 73 minus 8. 73 minus 8 is 65. And then I can take 20 minus 7, which is 13, and I keep my denominator of sixteenths. So now I didn't even have to worry about simplifying, changing an improper to a mixed number. All I had to do was borrow to make my fractions a little bit more friendly.